Hi, 8th grade. Today we're going to begin a new chapter. This chapter is about solving inequalities. And in this chapter you're going to be able to use many of the skills that you've learned in chapters 1 through 5. Today's lesson, 6-1, is solving systems of equations by graphing. At the end of today's lesson, you will be able to identify solutions of linear equations in two variables and solve by graphing. Feel free to pause during this video if you need to take notes or rewind it to watch again so that you can understand. We're going to begin with the definition of system of linear equations. A system of linear equations is simply a set of two or more linear equations that has two or more variables. For example, 3x plus 2y equals 7, and y equals 4/5 x minus 2. This is a system of equations because there are two equations with two variables. The second phrase is solution of a system of linear equations. A solution to a system of linear equations is an ordered pair that makes each equation true. For example, x minus y equals 0, and 3x minus y equals 13 is a system of equations. The ordered pair 5, 2 is a solution to this system because when x equals 5 and y equals 2, it makes each of these equations true. Now let's do some examples. As I said, 5, 2 is a solution for the system of equations 2/5 x minus y equals 0 and 3x minus y equals 13. Let's see why that is true. Here's some steps to follow. Please follow these steps along with me and write them in your notebook. We'll check them tomorrow. Step 1 is to write each equation, which I did. 2/5 x minus y equals 0, 3x minus y equals 13. Our second step is to substitute 5 for x and 2 for y, and then show your steps at each point. We're doing the math here. 2/5 times 5 is 2, minus 2 is 0. 0 equals 0, checks. In our second equation, we get 3 times 5 minus 2, which is 15 minus 2, or 13. 13 does equal 13. It does check. Therefore, our ordered pair 5, 2 makes both equations true. It is a solution. Now let's see what happens when you have an ordered pair that is not a solution for both sets of equations. Here are our two equations for example 2. X plus 3y equals 4. Negative x plus y equals 2. Step 1, write each equation. Step 2, substitute negative 2 for x and 2 for y. And then again do the math. Showing the steps we have negative 2 plus 3 times 2 becomes negative 2 plus 6, which equals 4. 4 does equal 4. This is a solution for the first equation. In our second equation, however, we get the opposite of x, or negative x, plus y equals 2. When you substitute negative 2 for x, the opposite of negative 2 becomes a positive 2. 2 plus 2 is 4. 4 does not equal 2. This is a false statement. This does not make the system true because it does not make the second equation true. Negative 2, comma 2 is not a solution. Now I'm going to show you how to solve a system of equations by graphing. We're going to use the lines y equal x and y equals negative 2x minus 3. Remember the equation y equals x has a y-intercept of 0, so we'll put the first point at the origin. This equation has a slope of 1 because the coefficient of our x term is 1 if you don't see the number. To make our second point, we go up 1 over 1, and using our ruler, we draw a line through the 2 points. Finally, label this line y equals x. Any point on this line is a solution to this equation. Now we'll graph the second line. The y-intercept of the second line is negative 3. Put a point on the y-axis at negative 3. Our slope for the second line is negative 2. This means we will have a line that goes in the downward direction. We will go down 2 and over 1 to find our second point. Finally, we will take our ruler and draw a line through the 2 points. If we've graphed correctly, we will see the point of intersection in this case is negative 1, comma, negative 1. But we have to check to make sure that this is the correct intersection point and that this is the solution. To check, we simply write our equations. And put in our points for x and y to see if it's true. The first equation, y equals x, simply becomes negative 1 equals negative 1. This is a true statement, which means this is a point on this line. The second equation, y equals negative 2x minus 3, we put a negative 1 in for y, equals negative 2 times negative 1 minus 3. Now we have to do the math. The left-hand side is still negative 1. On the right-hand side, we have negative 2 times negative 1, which is 2, minus 3. And yes, 2 minus 3 is negative 1. And we have our intersection point, which is negative 1, comma, negative 1. This is a solution to our equation, to our system of equations. We'll be doing one more example. Again, please follow along with me and work this example as well. I will be checking tomorrow to see that you have your work. Our second set of equations are y equals x minus 2 and 4y equals 1/2 x. Excuse me, it's 4y plus 1/2 x equals negative 8. The first equation is easy to graph. We see that our y-intercept is negative 2. We have a slope of 1. So to graph the second point, we go up 1 over 1 and draw a line through the 2 points using a ruler. I'm going to label the line y equals x minus 2. The second line, however, is not quite ready to graph. To graph the second line, we have to put it in slope-intercept form. So I'm going to solve this equation for y by first subtracting 1/2 x from each side, giving me 4y equals negative 1/2 x minus 8. And then I need to divide each side by 4. When I divide by 4, I must divide each term by 4. 4 divided by 4 is 1y, or y, equals negative 1/2 divided by 4. I know I'm dividing by a fraction, so I have to write the reciprocal of 4. This becomes negative 1/2 times 1/4 times x minus 8 divided by 4, which is 2. My last step is to multiply my fractions. I have y equals negative 1/8 x minus 2. Now my line is ready to graph. I have a y-intercept for this equation at negative 2, and I have actually found my intersection point because it is a point on this line as well. However, I'm going to finish graphing the line by going down 1 and over 8. So I'll go down 1 and over 8. Putting my second point on the graph, and then drawing a line through y equals negative 2 and the second point. This shows me my point of intersection, which is 0, negative 2. Finally, I'm going to check my work by putting my point into each equation. The first equation, y equals x minus 2, becomes negative 2 and 0 minus 2. 0 minus 2 is negative 2. Negative 2 equals negative 2. It checks. It's a solution to the first line. The second line, which is y equals negative 1/8 x minus 2, I'm going to write the equation. I'm going to put my ordered pair in for x and y. Negative 1/8 times 0 is 0 minus 2. And again, negative 2 equals negative 2. It checks. And my solution to the system of equations is 0, negative 2. That's all for today's lesson. Tomorrow we will practice doing some problems.